Hi and welcome to my tutorial on the derivation of centripetal acceleration. Okay, let's imagine you have a particle in circular motion and it's travelling from A to B through an angle of delta theta, and that's the radius. The velocity at A is v and the velocity at B is v dash. Okay. The first thing I'm going to say is that the magnitude of these velocities is exactly the same, so the speed of the particle is not changing. However, the direction is changing. As you can see, this velocity is going at this speed in this direction, and this one is going at this speed in that direction. So because the direction of the velocity is changing, then there must be acceleration, since acceleration is the change in velocity over time. So because there's a change in velocity, there is an acceleration, and the acceleration always acts towards the centre of the circle. The other thing I'm going to point out is this delta x here. As you can see, this delta x is an arc. The distance between A and B is an arc, but really this delta x is considered to be so small that it's a straight line. You imagine if you were to reduce the distance between A and B, so if A was here and B was here, then this delta x, rather than being sort of a curve, it would be a straight line. So you imagine this delta x is so absolutely tiny that it's considered to be a straight line, which means we have a nice triangle, which makes life a little bit easier when we get to things later. Okay, velocity is the change in distance over time. Now let's multiply through by delta t, so make delta x a subject. So delta x equals v delta t. But we also know that delta theta is the arc length divided by the radius, which is when the theta is in radians, because that is the definition of a radian, basically, that the arc length divided by the radius will give us the theta. So in this case the arc length is delta x, but remember that's so small that it's a straight line, so that's delta x divided by r. But we know that delta x equals v delta t, so let's sub that into here. So now we're going to have a new expression for delta theta, so delta theta equals v delta t over r, and this is going to be equation 1. Okay, let's go back to these velocity vectors. We want to know the difference in velocity between these two. And the interesting thing is, if you plotted the velocity over time, you'd end up with something pretty similar to this diagram. Since acceleration is the change in velocity over time, we can actually do that. So let's draw another circle. Sorry, the circle is really quite bad. Okay, let's have a look here. We've got this velocity vector here at A, which is going to translate to be this one here. This is at A, and the one at B, V dash, will be about here. So V, this is going to be at B. Now, the rules of, because this velocity vector is at 90 degrees to the radius, and again this one is 90 degrees to the radius, then if you have a look, that this angle here is going to be delta theta 2. It's the same delta theta as this delta theta, which does make sense. And the radius in this case is going to be v. It's going to be the speed, basically, of the particle. You think that because it's in circular motion, the speed is not changing, it's just a direction. So these vectors, as you go round, they sort of go round in a circle like this. But the radius is always going to be the same, it's always going to be v. It's just the direction of v that's changing. And in this case, the arc length is going to be the change in velocity. So that's going to be delta v. But again, remember that delta v is so small, like delta x, that it's going to be a straight line, which makes sense when you're looking at vectors and you want to find the difference between one vector and another. So if this is v and this is v dash, and remember that with vectors, when you want to find the difference between them, that you put them tail to tail. So this difference here is going to be delta v. And because this delta is so small, it is going to be a straight line, which goes with this, which makes life very, very nice. And we have an expression for delta theta, and that is that delta theta equals the arc length, which is a straight line in this case, which is going to be delta v from this delta v, over the radius, which we've already talked about, is going to be v. So now we have two expressions for delta theta. We have delta theta equals delta v over v, and we also have delta theta equals v delta t over r. So let's equate these two. So now we have, v delta t over r equals delta v over v. Now let's multiply through by r. So we have v delta t equals delta v times r over v. And now let's multiply through by this v. So now we have v squared delta t equals delta v times r. And now let's divide through by delta t. So we now have v squared equals delta v over delta t times r. And now let's divide through by r, and we end up with v squared over r equals delta v over delta t. And you might notice, and I hope you notice, that delta v over delta t is acceleration. So basically, we have derived acceleration from our little diagram. Yeah, very nice.